so here's our review. Let's go through it as a class. Number 1. Which graph represents a positive correlation? All right, Avery? Okay, so A is our answer. Oh.
It's C. That's a negative. That's a negative.
C. Now, this is our positive correlation. On A, what type of correlation do we have, Michael?
Negative.
Okay, this is our negative.
Hey.
On B,
A scatter.
what kind of correlation do we have here?
Scatter. No correlation.
Good. Scatter, no correlation. And on D,
Isn't that like a swing correlation?
No, it was
It's a banana correlation.
No, it's no correlation, but like, isn't that like a swing correlation?
non-linear. Okay, number 2. Said Jared collected data on the ages and heights of a random sample of elementary students. If he plots the data on a scatter plot, what relation will he most likely see between the ages and heights? When you do this one, I would have just done this and said age, height, and then I would have kind of just made it up as I go. If I do this, what do you think's going to happen to, if I say, here's a kid and their height, what do you think's going to happen? We know that age, they're going to have to get older. Eli's 7, my son. Next year when he goes to 6th grade, he'll be 8. He might act like a 50 or 5-year-old, but he will be 8. So his age will get better. What do we think will get at his height? Is he going to stay the same? Is he going to get taller? Or is he going to get shorter? He's probably going to be a positive. We should be seeing kids this age. We could be seeing it going as a positive. You could have a few outliers. One of our outliers, there could be my little peanut, Jude. He's short for his age, very short. That's why when you go to the doctor and they do your wellness check, they tell you what percentage for the height and the weight they were. Our kid, he's like in the 0%. I think last year he made the 1% finally for height. But normally we'd have a positive correlation. Okay, number 3. The graph shows that, I don't know why this comes weird on mine, the heights of dogs and the time it took the same dogs to complete an agility course in seconds. Oh, weight. I don't know why I said heights. Weight of dogs at the time it took the same dogs to complete the agility course in seconds.
It's height. It's weight.
Should be weight.
Yeah, but here it says height.
On yours it says height?
Yeah.
It should say weight. Anyways, which shows the line of best fit? Ainsley?
C.
C would be your correct answer. What is wrong with A? Wade?
It doesn't go through the middle.
Yeah, it's on the top part of all the dots. All the data is below it. What's wrong with B?
It's a line of mountains. It's too low.
Too low. Most of the data is above it. So what's wrong with D?
It's more parallel.
Doesn't make sense.
It's special.
Yeah, it's going up and down. It's going up and down. We did have this problem when we first looked at line of fit. Some people did that. They said, well, I have the same amount of dots on both sides. But remember, the dots are all supposed to be as close to the line as they can be. And here, they're not. We have to angle with our data. Okay, number 4. This is the one that I want to make sure we understand. This is usually our problem. You have a question? Okay. It says, Jill wants to know if she's improving on her skill on the cello. She created a scatter plot and drew a line of best fit. If she uses the point 2, 8, and 5, 1.5 from her line, what equation would represent the line of best fit? On here, we should all get the same answer. Now, if we did our own line of fit, we would get different answers. But since they're telling us the information, we should all do this the same. I want to make sure we understand something though. This is my line of fit.
Really?
Ainsley. Okay, this is my line of fit. When we're trying to write an equation from this, I forget about all the data points now. I'm only looking at the line. And I'm going to follow my line from left to right, and I'm going to try and say, while I'm on that line, is there a place where I know the coordinates? So when Jill did hers, she went through and said, hey, I know this point. And she continued and said, this 1.5, I know this one. Ainsley, follow, I'm not just talking. So I have my 2 points. I'm going to write them down. This is what you should have done as well. We should have 2, 8, and 5 and 1.5. What is the next step we have to do before we're able to write our equation? Troy?
You have to do y2 minus y1, and then over x2 minus x1.
Good. And what does that give me when I find at y2 minus y1? What does that tell me? What is that equation solving for? Sierra?
Solving for the 1.9.
Mx plus b.
Well, what is that called?
Slope.
Our slope. This is how we find our m, which is slope. So, we do our work. This is x1, y1, x2, y2. We put this in. I have 1.5 minus 8 and 5 minus 2. 1.5 minus 8 is negative 6.5. I actually had a number of people ask me about this. Is that okay that that's a negative number?
Yeah,
Absolutely.
slope's negative.
Good. That was my next question. Our correlation and our slope is negative. So our slope equation has to be negative. All right, so our equation that we're trying to solve for is y equals mx plus b. We now know m. It's 6.5 over 3. Negative 6.5 over 3.
I simplified it down. Yeah, that's
Okay,
right.
how did you simplify that? How did someone else do this?
Because I divided it by 3.
Okay, so what is negative 6.5 divided by 3?
2.2. Rounded up.
Right. So the reason we wouldn't do that, because you would have to end up rounding on that, because 3 does not go into 6.5 even. And another person last hour, they tried dividing by 0.5, and they ended up with negative 13 over 6. And all they did was really make their fraction bigger. When we simplify, is the biggest thing you want to look for is, can I divide by a whole number? Can I divide them evenly by something? On that one, no. When I divide by 3, 3 does not evenly go into 6.5, so we wouldn't want to do that. Would I take off on it? Probably not. I mean, your slope would change just slightly, and that's the problem. Even though it's a real small one, after time, it would give you a different answer. So just know not to. Just try and leave it there. But I like that you're looking at simplifying. All right, so we have our y and x. That always stays there. We know our slope. How do I identify my y-intercept? Troy? Okay, so we follow our trend line up to the y-axis. Here's my y-axis. And it looks like it's crossing right about there. Here's 10. Let's see, this is 9, 10, 11. Oh, I think we went by 2's last class. 9, 10, 11. So this is 12 up here. So what do we think it goes through, Wade? 12. This would be 11. That's about 12. We're estimating, so I'm going to say 12. If you said 11.5, that's going to be okay. For what we are doing, we are estimating our y-intercept. Next year in your math, They're going to show you how you find the precise number. It's just another formula, but we're not going to get into it. So I'm going to say it is 12. You write your equation. Y equals, slope was negative 6.5 divided by 3, x plus 12. Okay? What do we need? Do you need something? Zachary, move. Let her get tissues. Scoot into the desk.
Something about
Thank you.
Okay, I believe this is our last little page. Okay. Number 5, we're close to being done on this. So they did the hard part for us, which is going to be good. It says the table below shows the cost of flying from San Francisco to various other cities in the U.S. There's a relationship between the distance you are flying and the cost of your plane ticket. The data from the table is represented on a scatterplot. A. Draw the line of best fit and pick 2 points for the table that are on your line. So, I'm going to go on here. I don't know why that didn't go to my line. And I'll put my line in here. And let's I'll probably say my line somewhere like this. Now, could we have different answers on this one now? Yeah, because everyone's drawn their own line of fit. So yours might have been just a little bit off. The next point, after you draw your line of fit, this is the one that we talked earlier on. Follow your line from left to right to find 2 points that if you stopped on your line fit, you said, I know the coordinates. I look at mine. I'm going to zoom in big. I look for the easiest first. That one would be bad. Looks like mine are just barely off on that, so I'm probably going to count right in here. Probably half or right there. Well, I'm trying to look to see if I can say half. Well, I could say half here. I'll do that. So, my point is for my half right here. Man, I didn't want to erase it all. I'm going to erase just this first part there. This 0, since it's about halfway right there. So my 2 points that I should have chosen, your 2 might have been a little bit different than mine, but this is 220 or 250, and I think it goes up by 125 each time. So that probably won't be good to choose that one then. Or is that another one? We'll choose this. So we'll say this is about 500 and 150. And for this one, 1,250 and 225. Parker, put it down. You follow along with us. This is you just being distracted. So we've already had those. You have one right there, don't you? Okay, there's one up here. You're supposed to come to class with them, so we're not halfway through before you ask for it. Determine the equation of line of best fit. Same thing. I would have done y2, so 225 minus 150, 1,250 minus 500. Mine would come out to 110. So when I fail my slope, Tegan, are you doing this with me so you get credit for your assignment?
I'm watching you do it.
Okay, you need to fill out or you still get it for missing.
I actually learned how to do the line of fit though. I didn't know how to
Good.
do that.
So, we have one test. Yeah. So, there is what I would assume my slope would be. We still have to identify what my y-intercept would be, and I'd say it's just shy of 100. We'll just call it 100.
How come those points are like not like the bottom one? There's like a difference between the numbers because like one of them there's like a 50-point difference. Oh wait, hold on.
I know, I did the same thing, it's 25.
But then the bottom one too. Why is it like that?
Why are you asking me?
They didn't really do a good job putting these where they go. They were kind of off. It took me a while to figure that out, but we'll make sure it's clear on your test. So my equation would be y equals 1 over 10x plus 100. I will say the people that are kind of continually talking being off task, I expect you to get 100 then on this test.
Let's go.
And I'm not expecting to help you on your test if you have questions, because that's what we're doing now. The last thing is the very last question where you're having to do it all. That's going to be a big part of your test. Pretty much the biggest part is, can you put everything you have learned together? Parker?
Please go use the restroom.
All right, now we're doing this review. In just a second, you will be able to.
I understand.
So, on number 6, I want to go through a big component of it. It says the table below shows the sales of a flour company for the years 2007 through 2012. Answer the questions about this table. I'd say the first thing to do is go ahead and read through your questions. So, graph the data on the scatter plot and draw a line of best fit for the data. We know how to do that. Here's our information. Write the equation for the line of best fit for the data. Let X represent the years since 2000, Y represent the sales in thousands of dollars, and C, according to your equation, in what year would the sales reach about 500 in thousands? Use mathematics to explain how you determined your answer. So because of B, when I do my x-axis, I'm going to actually say since 2007. So this first one's going to be 0. So when I go ahead and make this on my x-axis, instead of writing the years 2007, 2008, 2009, and so on, I'm going to say this is 0. Then this is 1, 2, because this is 2 years since 2007. 3 years, 4 years, and 5 years. So I'm going to look at my graph here. And I know I have plenty of space to do so. So to help me, I'm going to go ahead and say, I'm going to skip by half a year, by 0.5. So I'm going to go 0, half, 1, 2, 3, 4, 5, and 6. And I should have enough covered there. Remember, we want to use as much of our scatter plot as possible. After you've done this, I already know some people are missing this, you must label. What is this standing for? So this is years since 2007. If you have 0, 1, 2, 3, 4, 5, and you say years, I am taking half credit off. Because this is not just years. We're not in year 1. We're not in year 2. You have to be mentioned that we're since 2007. Yeah, if you wrote the years, it might make this a little difficult. You'll have to see. Okay, to do my y-axis, this is the one I wanted to pause on because I want to make sure we understand scale. Show me you're doing this with us. How do I find my scale? Miles?
So you find the highest number and
Highest number, lowest number. And so I'm going to do 420 minus 305. And that gives me 115. 115 is my range, which means my scatter plot's going to range over 115. We then went ahead and we do 115 divided by how many lines we have. So I'm going to divide it by 12, and we come out with 9.538. We're not going to skip count by 9.538. We'll go ahead and round this to a scale of 10. Now, here's the important part. Do I go 0 to 10?
No.
The first line should be what?
0.5. 10.
Well, I do have to do the squiggly line. But what should that first point be then? No. Close.
305.
Why 305? Good. It should always be what we said our lowest number is. So 305. Now me, this is just my personal preference. I don't like writing up every single line. I am going to stay with the scale going up by tens, but I'd say 315, 325, 335, 345, 355, 365, 375, 385, 395, 405. Okay? You can write on every single line if you want. I just don't like it. I think it gives us too many numbers. We started at 305, and that's because that was our lowest value. Okay, then we go ahead and just plot our points. So in 2007, we were at 305. In 1, 330. At 2, 345. 370. In 4, 395.
So what did you start at? 305.
We started at 305 because that was our lowest point that we had. In year 5 and 420. So that's actually going to be up here just off my graph, just a touch. Okay. The next big thing we have to do. Ooh, there's 2 things I forgot to do. I'd lose half points on each one. What did I forget to do? That's
I know.
easy.
You forgot to title the years.
Title and the label. So this is sales in thousands, right?
Hundreds. Oh yeah.
Thousands. And then my title, they gave it to me right there. So I'd say flower sales. Okay, we have our points. Then we have to go ahead and make our line of fit. Mine would probably. Something like that. As far as write the equation for the line, once again doing slow. So if I look, easy points to graph. Let's say this one. I have that right on the dot. So that one was 0.305, and I'd say that one. So that is at 3, and that's 370. Okay, finding our slope. What?
This class is like the best class ever.
Something like that.
I'm in here.
370. Find your slope again. Remember slope, y2 minus y1 over x2 minus x1. I'd find this to be 65 over 3. Okay, that's my slope. My y-intercept is 305. So for this one, I have my equation as 65 over 3x plus 305. That's a big y-intercept, but it's okay because it fits with our data. Last question. And this is the last thing, and this is the big one, because I had a couple people make mistakes on this. When we are interpreting this, according to your equation, in what year will the sales reach about $500 in thousands? Use mathematics to explain how you determine your answer. Okay, when we're interpreting a graph and they're asking the question, I'm looking for 500,000. Do I see that on my graph? Can I visually answer this?
No.
It's not on my graph. Does 500,000 represent my x-axis or my y-axis?
Y-axis.
It's my y-axis. A lot of the examples we have done up to this point have been replacing the x. But if you look at this one, x is the years, y is the sales. So because of that, when you solve this one, I'm going to use my equation right here, but instead of y, we write down 500 equals 65. So we write out the rest of our equation. We are solving for x this time. All the other times in our practice, we've done a lot where we've solved for y. We've replaced x. This one's backwards, but it's nothing different. You still solve for x, so I minus 305. And this would become 65 thirds. This would be 195. How do I get to x? Wait. No.
Well, then I failed life.
Oh, I know. Oh, wait.
And now I have 195 equals 65 over 3 times x. How do I get my x by itself? Troy? So how do I divide 65 thirds? What do we do when we have a fraction times our variable? How do we get rid of the fraction?
Take away.
Multiply by what?
Right, and I was like,
You're right, you're getting there. We multiply, but what do we multiply by?
No, I have a question. Oh, so I put 500 in for y.
Yeah.
Is that right? And then
That's
you
Yeah, that's
Yeah.
what we did.
and then you you subtracted it, and then you divide. Oh, I did not get that. I got 20.
Because our slope, we probably had a different.
Yeah, I got 20 for my slope, so it was even. Never mind, guys. Don't listen to me.
How do I get? We're still in the same question. We've done this before.
65 times
It what?
65 times 3.
I can smell that from
65 times 49.
Really close. When we're multiplying a fraction, I should have people listening because obviously we don't know this answer. When we have a fraction times a variable, to undo the fraction,
turn the variable into a fraction, or you plug it in for x and then you turn x into a fraction, don't you?
We don't want x in
well, the reason we didn't put x in for something is because, well, how do we get x alone? We have
Didn't you just
65
put y?
thirds times x.
Simplify.
X still
Here's how. Remember, when we solve the equation, this is like if I would have given you just the equation and said, hey, what's x equal? And I say 195 equals 65 thirds x. To get rid of the fraction, you multiply by the reciprocal.
I knew that. I'm so stupid.
And you do that on both sides. Because 65 thirds times 3 over 65, those end up canceling each other out and give you just 1. So I'd have x equals. I still have to do 195. So 195 times 3 is 585, and we divide it by 65. Ooh, this one came out even. It equals 9.
Oh, I got 10.
So my answer is, in what year? In 9 years, since 2007, so that would have been the year 2016.
I know this is off topic and it sounds. I need chapstick.
Okay, here's what you're going to do for me. That's this review. If you didn't have yours done, you can come show me all the work that if you have it all. For tomorrow, for your bonus, which you can work on right now, on OneNote, if you go in, here was our day 8 where we did the work on my content library. You'd have to go to my content library and copy this over, but I put in this extra review. I will make, if you do this one, I will make it worth extra credit where I will give you Starbucks for it. I can't give you points on your test for it, but I will give you Starbucks.
Sister Sissel.